What if there were places in the universe where the rules of reality simply stopped working? Where time slows to a crawl, space folds in on itself, and every known law of physics collapses into silence. Astronomers call these places singularities, the hidden hearts of black holes. To most, they are terrifying abysses, regions of no return. But to others, they are gateways, portals to new realms of understanding, maybe even to entirely new universes. Imagine standing at the edge of such a mystery, an invisible surface called the event horizon. To an outside observer, you would appear frozen in time, forever hovering at the brink. Yet to you, the traveler, the fall is unstoppable, and what lies beyond is a place no human eye has ever seen. Is it destruction or rebirth? The end of physics or the beginning of something far greater? Tonight, we descend into the strange world inside a singularity where infinity meets imagination and where every answer only leads to deeper questions. The journey will challenge everything we think we know about the universe and about ourselves. The abyss beckons. In the quiet darkness of the universe, there are places so strange, so absolute in their silence, that they defy every instinct we carry about reality. Stars burn, galaxies collide, planets spin in endless dances. But in these places, all that movement collapses into something far more profound. The ancient word abyss may come closest to describing it, though even that falls short. Astronomers have given it another name, singularity. At its heart, a singularity is supposed to be a point, but not just any point. It is the end of points, the place where the known laws of physics, our carefully built rules and equations, shatter under pressures too intense to describe. To speak of a singularity is to speak of infinity, and infinity is not something our minds were ever built to hold. The story begins with a star. Imagine a star much larger than our sun, glowing for millions of years, fusing hydrogen into helium, creating the light and warmth that feeds entire systems of orbiting worlds. Like all living things, a star has a lifespan, and when it exhausts its fuel, the outward pressure of its fiery heart can no longer resist the inward pull of gravity. The star collapses. If it is small, it may fade into a white dwarf or crush itself into a neutron star. Strange, dense remnants that still carry echoes of their old brilliance. But if the star is truly massive, no known force can resist the collapse. It falls inward endlessly, shrinking, compressing, devouring itself until all that remains is a black hole, a region of space-time where even light cannot escape. And at the very heart of this black hole, according to general relativity, lies the singularity. The word alone carries a chill. Singularity. It suggests uniqueness, something set apart from everything else. And it is. At the singularity, density is said to be infinite, volume zero, and the fabric of space and time bent into forms no human intuition can truly picture. The equations of Einstein's general relativity, which work so beautifully to describe planets, stars, and even galaxies, break down at this extreme. Numbers collapse into infinities. Predictions dissolve into contradictions. Physicists call it a failure, but perhaps it is more honest to call it a mystery. A message that says, here, your understanding ends. What does it mean to even think about a place like this? Infinity, after all, is not a number. It is not a place we can reach, or a distance we can walk. It is the whisper of mathematics when it runs out of answers. To stand before a singularity would be to stand before the unknown made real. That is why the singularity has fascinated thinkers, poets, and scientists alike. because it forces us to admit that there are regions in the universe where not just our knowledge, but the very structure of reality itself becomes unrecognizable. Imagine for a moment drifting towards such a place. Far from the black hole, you might feel nothing unusual. Space would look like space always does, silent, cold, speckled with stars. But as you approach, subtle distortions begin to appear. Light bends in strange arcs around you. The stars ahead smear and twist into rings of brilliance, pulled by the gravitational lensing of the massive object hidden at the center. Closer still, you would see the accretion disk, a halo of gas and dust spiraling in at near light speeds, heating up until it glows brighter than any sun. It would look almost alive, this whirlpool of fire, turning endlessly around a darkness that seems to devour everything, yet reveal nothing. And beyond that spinning storm lies the event horizon, the boundary, the edge, the point of no return. To cross the event horizon is to step into the abyss. For an observer watching from a safe distance, the moment would never come. They would see you falling more slowly with every passing second, your light stretching into red, your image fading until you seemed frozen on the edge of forever. But from your perspective, the fall is swift and inescapable. Once inside, every path leads inward. Space itself seems to funnel you toward the singularity, and time itself appears to accelerate the closer you come. The abyss pulls you not just in space, but into the future, a future that ends in the singularity itself. The first explorers of these concepts were not astronauts or adventurers, but mathematicians. When Karl Schwarzschild solved Einstein's equations during the First World War, he discovered that under certain conditions, space-time could fold into a sphere of such density that nothing could escape. Later, others refined this idea, giving it boundaries, names, and conditions. But even then, many dismissed it as a curiosity, a trick of equations, never to be found in the real universe. It was only in the 20th century, when astronomical observations began to reveal objects too heavy, too compact, and too dark to be anything else, that black holes were accepted as real. And with them, the reality of singularities followed. Yet, though we accept their existence, we cannot see them. We cannot peer into the heart of a black hole and measure what lies beyond the horizon. Telescopes can trace the glowing disks of matter around them, or the strange dance of nearby stars being pulled into their orbit. But the singularity itself is forever hidden. It is a secret wrapped inside the universe's deepest vault. That secrecy is part of its power. It allows us to imagine, to speculate, to invent. Perhaps what we call the singularity is not truly infinite at all, but some exotic state of matter, some form of space curled upon itself. Perhaps it is a bridge to other dimensions, or the seed of new universes. In the absence of observation, possibility thrives. But possibility can also be terrifying. If singularities truly exist, they represent a boundary beyond which not even our most trusted physical laws can guide us. Imagine building a map of the world, carefully drawing each mountain, each river, each coastline, and then discovering a place where the ink cannot hold, where the lines blur and vanish, where the page itself tears open into something beyond the paper. That is what singularities represent, the tearing of our cosmic map. And yet, humans have always been drawn to the edges of maps. We look at the blank spaces, the unexplored regions, and we ask what lies there. The abyss beckons because it is unknown. It calls to us with silence, with mystery, with the promise that beyond its horizon lies something more. We cannot resist wondering. For some, it is enough to say it is an end. A singularity swallows matter, energy, light, and time. For others, it is tempting to think of beginnings. Could a singularity be a womb as well as a tomb? Could the collapse of one star give rise to the birth of another universe, hidden beyond our perception? These questions press against the very limits of science and philosophy alike. Even the language we use struggles to capture the idea. To say infinite density or zero volume is to step outside the realm of ordinary experience. Our lives are built on finite things, finite distances, finite times, finite weights. Infinity is a concept that lives in our mathematics, not in our hands. And yet, when we confront singularities, we are forced to treat infinity as though it were a part of reality. It is a contradiction, a paradox, and yet it may be the closest thing we have to truth. At night, when the sky clears and the stars shimmer above, it is humbling to think that among those tiny points of light are monsters, black holes, each one cradling a singularity at its heart. They are not rare. Astronomers now believe that nearly every galaxy has a supermassive black hole in its core, millions or even billions of times more massive than our Sun, which means that nearly every galaxy cradles a singularity. They are everywhere, silent and unseen, holding galaxies together, shaping the very architecture of the cosmos. The abyss is not far away. It is the very foundation on which our universe is built. And so, the story of singularities is not a story about distant corners of the universe. It is about us. Our galaxy spins around one. Our lives, though far removed, are still connected to the hidden influence of these impossible objects. And perhaps, in some distant future, humanity will come face to face with the abyss, not in equations, but in reality. What would we find if we crossed the horizon? Would we meet infinity, or would we discover that the abyss holds secrets far stranger than even infinity can describe? For now, the abyss remains closed to us, but it is there, waiting. And as long as it waits, we will keep asking. The singularity beckons, not with answers, but with questions. Questions that draw us deeper into the mystery of existence. And so we stand at the edge, gazing into the darkness, listening to the silence, and feeling the pull of the abyss. At the edge of forever. There is a line in the universe that is unlike any other. It has no color, no glow, no surface you could ever touch. It is not built of matter, nor is it marked by light. It is a boundary that is defined not by what is there, but by what can never come back once it is crossed. Astronomers call it the event horizon, and it is here, at this invisible frontier, that reality begins to twist into forms no human being was ever meant to see. The event horizon is the edge of the abyss, the point of no return. To imagine what it means, think of the speed of light, the cosmic speed limit. Nothing in the universe can move faster than light, not rockets, not thoughts, not even the wildest dreams. The event horizon is the place where escape would require moving faster than light, which means escape is impossible. Whatever crosses the horizon, whether it is a beam of starlight, a fragment of dust, or an entire planet, is gone forever from the outside universe. Not even information can return. It is as if the horizon itself swallows stories, erasing all that crosses into silence. From far away, a black hole might look almost ordinary. We cannot see it directly, but we can see the things it devours. We can trace the bright halo of an accretion disk, the circle of gas and dust spiraling inward, heating until it blazes with a light brighter than entire galaxies. We can watch stars in the distance warp and bend, their light twisted around the gravity of the hidden core. But the event horizon itself appears as a perfect shadow, a dark sphere against the chaos of the surrounding fire. It is a silence in the middle of sound, a stillness in the middle of violence. If you were to drift closer to this boundary, you might not even realize at first that you had crossed it. There are no markers, no signs, no sudden shifts in color or texture. The boundary exists not in space, but in fate. One moment you could, in theory, still turn back. The next moment, no matter how powerful your engines, no matter how desperate your struggle, you are committed to the fall. The horizon marks the edge of possibility. Beyond it lies inevitability. Yet the strangest part of this story is not what happens to the traveler, but what happens to the observer left behind. Imagine standing at a safe distance, watching as a friend approaches the horizon. To your eyes, they never truly cross. They appear to slow down, their movements growing sluggish, their signals delayed. Light from their body stretches into longer and longer wavelengths, first red, then fading into darkness. Eventually, they seem to freeze on the edge, time itself grinding to a halt as they hover there, suspended for eternity. You could wait 1,000,000 years and still they would be there, fading, never quite gone. But from the traveler's perspective, time is different. To them, everything proceeds normally. The crossing is quick, without drama, without pause. They do not hover at the edge. They fall. To them, the universe outside seems to accelerate, stars racing forward in their lifetimes, entire epochs slipping by as they descend. Time flows differently near the horizon, bending and stretching in ways that make ordinary experience meaningless. It is as if two stories are unfolding at once, the story told by the observer and the story lived by the traveler. Both are true, and yet they contradict one another. This contradiction unsettles us because it cuts to the heart of what time really is. We like to think of time as absolute, a steady river flowing the same for everyone, everywhere. But the event horizon reveals that time is not a river at all, but a fabric, a flexible sheet that can stretch and warp. Einstein showed us this long ago. Clocks run differently under the pull of gravity. But near a black hole, that difference becomes extreme. Here, time is not just distorted. It fractures into perspectives that can never be reconciled. The event horizon, then, is not just a place in space. It is a place in time. It divides not only where you can go, but what you can experience. For the traveler, the fall is swift and merciless. For the observer, the fall never ends. To describe it is to confront the unsettling truth that reality itself depends on where you stand, on how you move, on what you are able to see. There is no single story at the edge of forever. There are many stories, and each is incomplete without the others. This duality has fascinated physicists for decades. If information cannot escape, then what happens to it? Does the universe truly allow knowledge to vanish? Or does it remain frozen on the horizon, encoded in some form we cannot yet understand? This puzzle is known as the black hole information paradox, and it remains one of the great unsolved riddles of science. Some believe that information is preserved in the faint radiation black holes emit, what Stephen Hawking called Hawking radiation. Others believe that the horizon itself stores it, stretched thin across its surface like a hologram. Still others imagine that it is gone forever, lost in the singularity, erased from the cosmic ledger. Each possibility carries consequences that shake the very foundations of physics. But even without those debates, the horizon itself is enough to inspire awe. To cross it would be to leave the universe as we know it behind. The stars would vanish from view, replaced by a darkness more complete than any night sky. Directions lose their meaning. Forward and inward become the same thing. Every step, every breath, every heartbeat carries you closer to the center. And though the singularity itself remains out of reach for now, the inevitability of the journey presses on you with every passing instant. What lies beyond the horizon is not just an open question, it is a forbidden one. No message can return, no light can escape. The horizon is a veil that hides the truth from all who remain outside. And yet, paradoxically, it is the veil itself that fascinates us most. We can never see what lies within, but we can see the edge, the shadow, the silence. And in that silence, our imagination takes root. Perhaps the horizon is not a wall, but a doorway. Perhaps what vanishes from one universe emerges in another. Perhaps every black hole is a passage, and every singularity a seed. Or perhaps it is simpler than that. Perhaps the horizon is what it appears to be, an end, an absolute, a silence so deep that it admits no echoes. Either way, to stand before it, even in thought, is to stand before the limits of human knowledge. The edge of forever is not just a phrase, but a reality. It marks the place where our measurements stop, where our theories falter, where our courage and our fear meet. It is the ultimate threshold, a place that invites us closer while warning us away. For the traveler, it is the beginning of a fall without end. For the observer, it is the end of all beginnings. And for both, it is the reminder that the universe is stranger, deeper, and more mysterious than we can ever fully grasp. So we linger here, at the edge. We watch the shadow. We trace the light that bends around it. We feel the pull of questions that have no answers. And as we do, we realize something profound. The event horizon is not just out there, in the distant reaches of space. It is also in here, in our minds, in the boundaries of what we dare to imagine. Every time we think about it, we cross a horizon of our own, leaving behind the familiar and stepping into the unknown. And as we step forward, the abyss waits patiently, silent and endless, inviting us deeper. The collapse of physics. There is a strange irony at the heart of modern science. The more successful a theory is at explaining the universe, the more we are tempted to believe it can explain everything. Newton's laws once gave us the confidence to imagine a clockwork cosmos, precise and predictable, every motion calculable in advance. Then Einstein's relativity revealed a deeper truth, that space and time are not rigid stages, but flexible fabrics, bending under the weight of matter and energy. With that revelation, physics seemed once again capable of describing the entire universe. But the singularity defies both Newton and Einstein. It is not simply a mystery waiting for discovery. It is the place where our maps of reality tear apart, where the very language of physics breaks down into silence. To understand why, we must go back to the beginning of relativity itself. Einstein's general theory, published in 1915, told us that gravity is not a force in the ordinary sense, but the warping of spacetime. A massive star bends the geometry around it, and planets follow the curves of that geometry as they orbit. It is elegant, beautiful, and almost universally confirmed. Relativity predicts the bending of starlight around the sun, the slow drift of Mercury's orbit, the ripples of gravitational waves racing across the cosmos. It is a theory of extraordinary power. Yet even Einstein's equations whisper of their own limits. They allow, under extreme conditions, for solutions in which spacetime curves infinitely upon itself. These solutions are singularities. When a star collapses beyond a certain threshold, relativity insists that there is no known pressure, no resistance strong enough to halt the fall. Gravity becomes unstoppable, space narrows, time bends, and at the center, the equations predict a point where density is infinite, volume zero, curvature unbounded. The mathematics do not merely suggest this, they demand it, and in demanding it, they reveal their own failure. For physics, infinity is not an answer, it is a confession. It is the way our theories say, beyond this, we cannot go. Consider what infinite density would mean. A teaspoon of matter from a neutron star already weighs billions of tons. Yet even neutron stars have limits. Push further, and neutrons themselves collapse, their resistance broken. At a singularity, there is no resistance left, no structure, no separation. Every atom, every particle, every quantum field is drawn into the same collapsing fate. All of it crushed, all of it falling, until the very notion of matter ceases to apply. What remains? Relativity says, infinity. But infinity is not a physical state. It is the absence of one. This is the collapse of physics. Our equations, which so confidently describe galaxies and atoms alike, dissolve into contradictions when faced with a singularity. They try to describe it, but the numbers they produce spiral out of control. We are left with infinities that cannot be measured, conditions that cannot be tested, a reality that cannot be imagined. And so, the singularity is both the most real and the most unreal place in the universe. Real, because the equations insist it must exist. Unreal, because the equations themselves cannot explain it. What makes this collapse more haunting is that it is not unique to black holes. At the dawn of time, the universe itself is thought to have emerged from a singularity. The Big Bang, as we call it, is not simply an explosion in space, but an explosion of space. If we trace the expansion of the universe backward, all galaxies racing inward, all stars converging, all time rewinding, we arrive at a point where the density becomes infinite. Once again, relativity delivers us to a singularity, and once again, it cannot carry us through. It shows us the doorway, but not what lies beyond it. Physicists often describe singularities as naked or clothed. A naked singularity would be exposed to the universe, visible to distant observers. A clothed singularity, hidden behind an event horizon, is shielded from view. Black holes are clothed singularities, their horizons acting as veils. Naked singularities, if they exist, would defy even the protections of the horizon, revealing their contradictions openly. Many scientists believe the universe forbids them, that some cosmic censorship hides the worst of infinities from our eyes. But even hidden, the singularity still haunts us. It is there, behind the curtain, a reminder that our physics is incomplete. Some have argued that the collapse of physics at singularities is not a failure, but a challenge. It tells us where our next discovery must lie. For if relativity breaks down at the singularity, then perhaps there is a deeper theory waiting to replace it. One that does not collapse into infinity, one that can weave together the large and the small, gravity and quantum mechanics into a single fabric. Physicists have spent decades chasing this dream. String theory, loop quantum gravity, holographic principles. All of them are attempts to build a map that does not tear at the singularity. Yet none has yet given us a definitive answer. The abyss remains uncharted. It is strange to think of the singularity as both nothing and everything at once. It is nothing because it cannot be described, measured, or observed. It is everything because it represents the ultimate limit of matter, energy, and time. In it, the universe collapses into a single point. Out of it, perhaps, the universe itself was born. Our equations stumble there because the singularity is not merely a region of space, but a boundary of knowledge. It marks the end of what we know and the beginning of what we cannot yet imagine. The collapse of physics at the singularity is not unlike the collapse of language when faced with the ineffable. Poets, mystics, and philosophers have long struggled to describe experiences beyond words, visions beyond sight. Their language bends, breaks, resorts to metaphor and paradox. Physics does the same at the singularity. It tells us infinity, zero, unbounded curvature. These are not descriptions of reality, but signs that description itself has failed. And yet, in that failure, there is an invitation to go deeper, to search for a new language, a new physics that can hold the weight of the abyss. Einstein himself was uneasy about singularities. He believed nature could not allow such infinities, that the equations must be hiding something, that a more complete theory would smooth them away. Yet, as evidence for black holes grew, so did the acceptance of singularities. They may not be comfortable, but they seem unavoidable. The universe insists upon them, whether we like it or not. And so we are left with this paradox. Our most successful theory delivers us to its own destruction. At the center of the black hole, physics collapses. To imagine standing at the edge of such a collapse is to feel both awe and unease. The stars above you still shine, the universe still spins, but below lies a place where none of it makes sense. It is like walking to the edge of a cliff in the dark, hearing the wind rush up from below, but never seeing the ground. You know it is there, you know it is real, and yet you cannot picture its shape. The singularity is a cliff in our understanding, and beyond it stretches the uncharted void. And yet, humans have always been drawn to cliffs. We walk to the edges of maps. We ask what lies beyond the horizon. The collapse of physics does not frighten us away. It lures us closer. Because if the singularity is the place where our theories fail, then it is also the place where new theories must be born. To confront the singularity is to confront the limits of what it means to know. And in that confrontation, we may discover truths greater than any we have yet imagined. For now, though, the singularity remains a silence in our equations, a blank in our maps. It is the reminder that even our most brilliant ideas are only steps on a longer journey. The abyss waits, patient and unyielding, until we can speak its language. Until then, we circle it, measure its shadow, feel the tremors of its pull. We know it is there, we know it matters, but we do not yet know what it means. And so, the collapse of physics at the singularity is not an end, it is a beginning, a call to venture deeper into the unknown, to search for a theory that does not break where reality bends. The abyss may hide its truths for now, but it cannot hide them forever. And as long as it remains, the journey of discovery continues, leading us further into the strange world inside a singularity. Time torn apart. Time has always been the one companion we could never escape. It carries us from birth to death, marking each moment with a relentless rhythm. We measure it with clocks, feel it in our bones, fear it in our endings. Yet time is also slippery, elusive, and deeply mysterious. It seems so simple in daily life, seconds, minutes, hours, flowing forward like a river. But when we approach the strange world of singularities, that river bends and twists until it becomes unrecognizable. Here, at the very brink of a black hole, time is not just distorted, it is torn apart. Imagine yourself falling toward the event horizon. From your perspective, the journey feels steady, unstoppable, natural. The blackness grows larger, the stars behind you seem to recede, and every second on your clock ticks as it always has. Yet to a distant observer watching through a telescope, your time begins to stretch. Each movement slows, each flash of light from your body grows longer and dimmer. They see you hesitate, stall, and finally freeze just outside the horizon. For them, your last second lingers forever, stretched into eternity. For you, it is only a heartbeat. Two stories, two truths, yet both are real. This is the first way time is torn at the edge of a singularity. It ceases to be universal. There is no single answer to the question, what time is it? In the presence of overwhelming gravity, time fractures into perspectives. Your watch insists that only a few moments have passed, while a distant star might say 1,000,000 years. This is not illusion. It is the fabric of space-time itself reshaping, bending the flow of moments into different currents for different observers. And it is only the beginning. As you fall closer, something more radical occurs. In everyday life, space and time are separate. We move freely through space, but we are carried forward by time whether we want to be or not. Past, present, future, they march in order, one after the other. Yet near a singularity, space and time begin to trade places. Directions collapse. Movement inward becomes movement forward in time. You cannot choose to stop falling, just as you cannot choose to stop aging. The geometry of space-time demands it. Once you have crossed the horizon, the singularity is no longer just a place in space. It is your future, and the future cannot be avoided. This is perhaps the most haunting feature of black holes. They do not simply trap you in space, they trap you in time. To fall inward is to step onto a path that no force, no engine, no wish can ever divert. You are not being pulled. You are being carried into tomorrow, and tomorrow always ends at the singularity. It is as if the universe has written your fate into the very structure of space-time, and all you can do is live it out. But time does not only bend for those who fall, it bends for those who remain outside as well. The black hole's gravity stretches not only clocks, but light itself. Waves of energy are pulled and elongated, transformed into lower and lower frequencies. A photon that might have left your ship as visible light could reach the outside as a faint whisper of radio. To the observer, you become redder, dimmer, until you fade completely. And yet, from your own perspective, nothing unusual has happened. Your flashlight still glows, your heart still beats, your watch still ticks. Once again, time has split itself into truths that cannot be reconciled. This tearing of time leads to paradoxes that gnaw at the foundations of physics. What does it mean to freeze on the horizon forever while also crossing it in seconds? Where is the real story? Einstein's equations allow both, depending on where you stand. But to us, bound by the idea of a single timeline, it feels like a contradiction. Perhaps, though, the contradiction lies not in the black hole, but in our limited way of thinking. Time has never been as simple as we imagine. The singularity merely forces us to face the truth. Time is not a universal stage, but a tangled web, and every observer weaves their own thread through it. The closer we approach the singularity, the more tangled that web becomes. The mathematics suggest possibilities that verge on the fantastical. time may not only slow or accelerate, it may loop. In some exotic solutions to Einstein's equations, closed time-like curves appear, paths through spacetime that lead not forward, but back to the same point. In such a universe, time is not a line, but a circle, forever repeating. Could singularities harbor such loops? Could falling into a black hole mean falling into an eternal cycle of repetition, a life lived again and again with no escape? No one knows. The equations allow it, but reality has not yet confirmed or denied it. And then there is the ultimate question: what happens to time at the singularity itself? If density becomes infinite, if space shrinks to nothing, then what of time? Does it stop? Does it cease to exist? Or does it transform into something we cannot yet name? Some physicists suggest that time as we know it ends there, that the singularity is not a place, but a boundary, beyond which the very concept of before and after no longer applies. Others speculate that the end of time in one universe may be the birth of time in another, that the singularity could act as a seed, giving rise to new space, new time, new beginnings. To contemplate this is to confront our deepest assumptions. We take time for granted. We rely on its steady flow for meaning, for memory, for identity itself. Without time, who are we? Without past and future, what is existence? The singularity forces us to face a possibility that is at once terrifying and liberating. That time may not be fundamental, that it may be an emergent property, a byproduct of deeper laws we have yet to uncover. If time can be torn apart, then perhaps it can also be rebuilt, reshaped, reimagined. Even Stephen Hawking once described the inside of a black hole as a place where time itself seems to point inward. It is not that space pushes you down, but that time carries you there. In this sense, the singularity is not a location you fall into, but a moment you reach, as inevitable as the ticking of a clock. The horizon becomes a kind of temporal, one-way street. Once you pass it, all futures lead to the same destination. It is a sobering vision. No matter what you do, no matter how you struggle, the singularity is in your tomorrow. And yet, outside, the black hole plays a different game with time. To the rest of the universe, black holes act as archivists. They keep the past alive in frozen images of all who approach. They preserve the echoes of falling matter, stretching them across eternity. The traveler is gone, yet the ghost remains, lingering on the horizon. In this way, black holes fracture time not only for those who fall, but for those who watch. They force the universe to carry multiple versions of the same story, suspended side by side, never reconciling, never agreeing. Perhaps this is why black holes and their singularities feel so haunting. They do not simply consume matter, they consume certainty. They show us that time, the very medium of our existence, is not as solid as we once thought. It can stretch, bend, tear, even vanish. And if time can vanish, what does that say about us, who are nothing more than creatures carried by its flow? It may be that when we peer into the abyss, what unsettles us most is not the collapse of stars or the pull of gravity, but the realization that time itself is fragile. That the seconds we cling to, the minutes we treasure, the lifetimes we build, all of it could unravel under conditions we barely understand. In the presence of a singularity, time is no longer a river. It is a storm, spinning, breaking, reforming, carrying us into fates we cannot escape and cannot comprehend. And yet, in that storm, there is also wonder. For if time can be torn apart, it can also reveal new shapes, new possibilities. Perhaps black holes are not only ends, but beginnings. Perhaps what looks to us like the death of time is, in truth, the birth of new times, new universes, new lives. In that sense, the singularity is not only a tomb, it may also be a womb. And if so, then time is not destroyed there. It is reborn in forms we cannot yet imagine. As we drift away from these thoughts, carried by the silence of the cosmos, we realize that black holes do more than challenge our physics. They challenge our imagination. They ask us to picture a universe where time itself is fluid, where futures and pasts are not fixed, but malleable, where eternity can stretch in an instant and a moment can last forever. And in asking us to imagine this, they remind us that even as time may be torn apart, our curiosity endures. Because if time can end, if it can be rewritten, then perhaps so too can our understanding. And with every question we ask, we step closer to that abyss, daring to glimpse what lies inside. Quantum clues. When we look at the universe on the largest scales, Einstein's relativity rules with elegance and certainty. Galaxies move in great arcs, stars bend the fabric of space-time, planets follow their curved paths as though tied to invisible strings. But when we look at the universe on the smallest scales, relativity falters. Here, another framework takes command. Quantum mechanics. Atoms, particles, fields, probabilities. This is the domain of uncertainty, of sudden leaps and ghostly waves, of a reality that flickers rather than flows. For nearly a century, these two great theories, relativity and quantum mechanics, have stood side by side, each describing its own kingdom with unrivaled accuracy and yet refusing to unite. And nowhere is their refusal more glaring than at the heart of a singularity. The singularity is where the very large and the very small collide. A collapsing star compresses itself past all known limits, crushing matter until quantum scales are forced to reckon with gravitational extremes. Relativity demands infinite density. Quantum mechanics whispers that infinities cannot be real. The result is a paradox, a place where our two greatest theories contradict each other. The singularity becomes the ultimate laboratory, if only we could reach it, for testing which description of the universe is truly complete. The first quantum clue comes from a simple idea. Perhaps singularities do not really exist. Perhaps they are not physical objects at all, but signs that relativity has been pushed too far. In this view, the infinite density predicted by relativity is not reality, but an error, the kind of nonsense that happens when you divide by zero. Just as Newton's laws break down at speeds close to light, relativity may break down at the Planck scale, the unimaginably tiny realm where quantum effects dominate. If that is true, then inside a black hole, space-time might not collapse into nothingness. Instead, it might crunch into something new, something exotic, something profoundly different from anything we have ever seen. What could this something be? One possibility is the Planck star. Born from attempts to combine relativity with quantum mechanics, the Planck star is not a point of infinite density, but a small, incredibly dense core, stabilized by quantum effects. Instead of collapsing forever, matter rebounds at a size so small we cannot yet measure it, held there by the pressure of space-time itself. To the outside universe, hidden by the event horizon, it would look like a black hole. But deep inside, it might be a structure rather than a singularity, a remnant instead of an end. Another possibility comes from the concept of space-time foam. At the tiniest scales, quantum mechanics suggests that space and time themselves are not smooth fabrics, but restless seas, bubbling and frothing with fluctuations, Particles appear and vanish in an instant. Fields ripple with uncertainty. Geometry itself wavers like heat rising from pavement. If this foam is real, then the singularity may dissolve into it. Instead of a sharp point of infinity, the heart of the black hole might be a storm of quantum geometry, chaotic yet finite. In such a place, the very notions of distance and time could lose their meaning. The singularity, then, would not be destruction, but transformation. Still other clues emerge from quantum field theory, which teaches us that even in the vacuum of space, energy is never truly absent. Virtual particles flicker into existence, pairs of opposites born and annihilated in the blink of an eye. Near the event horizon, this quantum activity takes on profound consequences. Stephen Hawking realized that these fluctuations could allow black holes to radiate, ever so faintly, like hot coals in the night. A black hole, once thought to be eternal, slowly evaporates through this Hawking radiation. And if it evaporates, what then of its singularity? Does the collapse persist until the very end? Or does the radiation carry away not only mass, but information, dissolving the paradox itself? Here lies one of the most important quantum clues of all, the information paradox. Quantum mechanics insists that information, the details of a system, the arrangement of its particles, the history of its state, can never truly be destroyed. Relativity seems to say otherwise, that what falls into a singularity is erased from the universe forever. Which is true. If information can be lost, then the foundations of quantum theory crumble. If it cannot, then our picture of singularities must be incomplete. Black holes, it seems, are not only cosmic traps, but cosmic riddles, challenging us to reconcile the irreconcilable. Some physicists believe the answer lies in holography. Imagine that everything inside a region of space could be described by information stored on its boundary, as though the universe were a hologram projected from a surface. Applied to black holes, this principle suggests that the information about what falls in may not vanish, but may be encoded on the event horizon itself, stretched across its surface like patterns on a cosmic screen. In this picture, the singularity is not the end of information, but its deepest vault. What looks like destruction may, in truth, be preservation in disguise. Others push the imagination further. Perhaps black holes are not dead ends, but bridges. Wormholes, tunnels through spacetime predicted by certain solutions to relativity, could connect black holes to other regions of the universe, or even to other universes entirely. In this view, the singularity might not be a crushing point, but a gateway, a hidden passage where quantum effects stitch spacetime into new configurations. The traveler who falls in might not be destroyed, but transported, though to where, no one can say. It could be another star system, another dimension, or a universe beyond imagining. These ideas are speculative, yes, but speculation is not weakness. It is the lifeblood of discovery. Every great theory of physics began as speculation, a daring attempt to see beyond the boundaries of known knowledge. Singularities demand speculation because they forbid observation. We cannot look inside. We cannot send probes. We cannot run experiments. All we have are the clues scattered at their edges, the radiation, the gravitational waves, the shadows imaged by telescopes. From these fragments, we try to reconstruct the truth. And the truth seems to be this: relativity alone is not enough. We need quantum mechanics to complete the picture. But quantum mechanics is not without its own mysteries. It tells us particles can be waves, that existence itself is probabilistic, that reality does not take on definite forms until it is observed. What does this mean inside a singularity? Could the heart of a black hole be a place where reality itself flickers, uncertain, undefined? Could the singularity be not a place at all, but a superposition of possibilities, waiting for some deeper observation to collapse it into form? The thought is dizzying, but it may not be far from the truth. When we follow quantum clues, we find ourselves drawn not to final answers, but to deeper questions. Is space-time discrete, made of indivisible units like the pixels of a screen? If so, then singularities might never truly form, for the collapse could halt at the smallest possible scale. Are there hidden dimensions beyond the three of space and one of time we know? If so, the singularity might spread into them, escaping the trap of infinity by spilling into realms we cannot yet see. Does information live forever, carried on the surface of horizons, or encoded in subtle correlations of radiation? If so, then black holes are not destroyers, but archivists, guardians of the universe's memory. Each clue points us toward a grander theory, something physicists dream of: quantum gravity. A theory that would marry relativity and quantum mechanics, uniting the large and the small into one harmonious picture. Such a theory would not break at singularities. It would describe them with clarity, reveal their true nature, explain their paradoxes, and show us whether they are ends, beginnings, or something in between. The search for quantum gravity has driven generations of scientists, and though it remains elusive, the singularity keeps it alive. For as long as singularities remain unexplained, the need for that deeper theory remains undeniable. And so, when we peer into the abyss, we are not staring into emptiness. We are staring into a puzzle, a riddle written in the language of both relativity and quantum mechanics, waiting for a key to unlock it. Every quantum clue we gather, every photon of Hawking radiation, every ripple of space-time detected by gravitational wave observatories, every shadow imaged by telescopes at the edge of the horizon, brings us closer to that key. We do not yet know what it will reveal, but we know this: the singularity is not just the collapse of matter. It is the meeting place of our deepest ideas, the crucible where the future of physics will be forged. Perhaps, then, the singularity is not a failure of knowledge, but its invitation. It beckons us with riddles, teases us with contradictions, dares us to imagine beyond infinity. And in following its quantum clues, we may one day uncover not just the truth of black holes, but the truth of the universe itself. Exotic hypotheses. The singularity, in its starkest definition, is the point where the known laws of physics surrender. To many, that surrender feels like an ending, a place where we must turn back, admitting ignorance. Yet to others, the singularity is not an end at all, but a beginning, a doorway to possibilities so strange and so daring that they stretch not only science, but imagination itself. These are the exotic hypotheses, ideas born from the edges of theory, whispers of what might lie inside the abyss. The first and perhaps most striking of these ideas is that singularities may not be the final crushing points we imagine. Instead, they may be bridges. The mathematics of relativity does not forbid such bridges. It allows for structures known as wormholes, tunnels through space-time connecting distant regions of the universe. Imagine falling into a black hole, not to be annihilated, but to emerge through some distant mouth, billions of light years away, or perhaps even in another universe altogether. To some physicists, wormholes are not fantasy, but natural solutions hidden within the equations, their stability uncertain, but their possibility undeniable. If this is true, then black holes may not be tombs, but gateways. And yet, wormholes carry their own mysteries. Could anything survive such a passage? The tides of gravity near a singularity are fierce, stretching and compressing matter until even atoms are torn apart. To slip through a wormhole would require not only entering it, but surviving the journey. Exotic forms of matter, substances with negative energy density, are theorized to stabilize such tunnels, preventing their collapse. But such matter has never been seen, and perhaps never will be. Still, the idea lingers. Every time we gaze into the abyss, we cannot help but wonder, does it lead somewhere else? Another exotic hypothesis takes us in the opposite direction, suggesting that black holes do not connect to elsewhere at all, but to new beginnings. In this view, the singularity may act as the seed of another universe. The collapse of a star in our cosmos could spark a big bang in another, hidden from us behind the veil of the horizon. To us, it is an ending. To that other universe, it is a birth. Perhaps our own universe began this way, a singularity inside some greater cosmos. If so, then the multiverse may be populated not by random creations, but by black holes, each one spawning a universe of its own. The abyss becomes not an eraser, but a womb, giving rise to countless new realities. There are also theories of white holes, the imagined opposites of black holes. Where black holes consume matter and light, white holes would expel them, spewing radiation and particles into space. In relativity's equations, black holes and white holes are mathematically linked, two sides of the same coin. Some have speculated that a black hole in one universe could appear as a white hole in another, the matter swallowed in one cosmos bursting out into another in a blaze of creation. White holes have never been observed, and their stability is uncertain. Yet the idea that destruction in one place could be creation in another has a haunting elegance. Still, other hypotheses suggest that singularities may not form at all. Instead, when collapse pushes matter to extremes, quantum effects intervene. Loop quantum gravity, a candidate for uniting relativity with quantum mechanics, predicts that spacetime itself is quantized, made of tiny indivisible units. If so, then matter cannot collapse indefinitely, for spacetime itself resists beyond a limit. Instead of a singularity, the collapse may halt at a minimum volume, rebounding into a new phase. This bounce could prevent the infinite densities predicted by relativity, replacing them with finite, though extreme, conditions. Inside the black hole, instead of a singularity, there might be a Planck-scale star, invisible but stable, holding the secrets of the collapse without succumbing to infinity. To think of such structures is to realize how little we truly know. Are black holes the universe's graveyards or its gardens? Are they prisons or portals? The exotic hypotheses remind us that we cannot assume the answers. They force us to stretch our imagination, to picture the cosmos not as a rigid machine, but as a living story with chapters we have yet to read. One particularly daring hypothesis imagines that black holes are not singular at all, but holographic. Information about everything that falls into them is encoded on their surface, projected inward in ways we cannot yet comprehend. To the outside universe, the black hole appears simple, a dark sphere defined only by its mass, charge, and spin. But hidden in that simplicity may be infinite complexity, the full history of everything swallowed, preserved in holographic form. In this sense, the singularity is not the end of information, but its transformation, a vast library written on a surface no one can open. Another possibility draws from string theory, where particles are not points but tiny vibrating strings, their harmonies giving rise to matter and force. String theory suggests extra dimensions, curled up and hidden from our senses. Could a singularity extend into these dimensions, spilling its secrets into realms we cannot see? Could black holes be the gateways through which higher dimensional physics reveals itself? In this vision, the abyss is not simply a place of destruction, but a crack in the wall of reality, a place where we glimpse the scaffolding of a deeper universe. And then there are the boldest speculations of all, that singularities may be conscious, in some alien sense of the word, that the patterns of information compressed within them could give rise to awareness, intelligence, thought beyond comprehension. Such ideas are more philosophy than physics, yet they capture the imagination. For if singularities are the densest repositories of matter, energy, and information in the cosmos, could they not also be the densest repositories of mind? Could black holes be not only objects, but observers, watching silently from their horizons, their thoughts hidden beyond the reach of light? We must tread carefully here. The line between science and speculation is delicate. Exotic hypotheses are not certainties. They are explorations, attempts to imagine what lies beyond our data. Yet they serve a purpose. They remind us that the universe may be stranger than our equations, richer than our expectations, deeper than our imaginations. They keep us from mistaking the limits of our knowledge for the limits of reality. When we speak of singularities, it is tempting to reduce them to abstractions, to infinities and paradoxes. But the exotic hypotheses invite us to see them as possibilities, as openings rather than endings. Wormholes, white holes, Planck stars, bouncing universes, holographic horizons, each is a story, a way of reading the same riddle. None may be true, all may be false. Yet in exploring them, we stretch ourselves. We prepare for the possibility that when we finally peer beyond the veil, what we find will be stranger than anything we dared to imagine. And perhaps that is the real gift of these hypotheses. They do not give us answers. They give us courage, the courage to ask questions that seem impossible, to follow threads that lead into darkness, to believe that even the abyss may hold wonders. Because if there is one lesson the universe has taught us, it is that the unimaginable often turns out to be real. Galaxies, once invisible, became countless. Atoms, once unthinkable, became fact. Time itself, once absolute, became flexible. Why should the singularity be any less strange? So we stand before it, this dark frontier, our minds filled with hypotheses as exotic as the abyss itself. We may not know which, if any, are true, but we know that the answers, when they come, will change not only our understanding of black holes, but our understanding of reality itself. And as the silence deepens, the abyss waits, patient and inscrutable, daring us to imagine what lies within, inside the darkness. The event horizon is a boundary we cannot return from, and the singularity is the place our equations collapse. But between those two lies a region that fascinates the imagination, the inside of a black hole. No light escapes from it, no information returns, and no traveler has ever emerged to describe it. It is the most private of all cosmic realms, sealed against the eyes of the universe. And yet, it is also the most haunting. For while we cannot see it, we cannot help but wonder, what does it feel like? What does it look like? What is the strange world inside the darkness? Step across the horizon in thought, and everything familiar begins to unravel. The sky, once filled with stars, vanishes behind you. The event horizon closes like a curtain, leaving only blackness in all directions. But this blackness is not empty. It is heavy, oppressive, saturated with the pull of gravity. You do not simply move inward. You are carried, swept as if by a current. Space is no longer a stage on which you move. It is a river in which you are caught. And time is the current itself, dragging you inevitably toward the singularity. The first sensation, if sensation were possible, would be of stretching. Gravity is stronger at your feet than at your head, stronger at one side of your body than the other. This difference creates what scientists call tidal forces, and inside a black hole, they become extreme. The effect has a chilling name: spaghettification. Matter is pulled into thin, elongated strands, stretched until its structure fails. Molecules tear apart, atoms separate. Even subatomic particles are twisted by the gradients of gravity. A person falling inward would not survive the journey. They would be unraveled into the very fabric of spacetime. Yet survival is only one perspective. From another, more abstract view, the inside of the black hole is not destruction, but transformation. The equations of relativity tell us that once inside the horizon, the singularity is not a point you move toward in space, but a moment you move toward in time. Just as you cannot stop tomorrow from arriving, you cannot stop reaching the singularity. Every path you take, every direction you try to move, leads to it. The geometry of spacetime itself has tilted, making the singularity your future. It is not a destination you might avoid. It is your destiny. And so, the strange world inside the darkness is one of inevitability. The walls of this universe close in, not physically, but temporally. The future narrows until it becomes a single point, and you are drawn into it whether you will or not. It is a terrifying vision, yet it is also strangely profound. For outside the black hole, time offers endless possibilities, branching futures, countless choices. Inside, there is only one: to reach the singularity. In that sense, the black hole strips life down to its purest certainty. What would you see on the way? It is difficult to say, for light itself cannot escape the inward flow. Photons curve around, fall inward, spiral with you. The universe outside might appear compressed into a shrinking sphere of distorted light, a final glimpse of stars warped by the horizon before they fade entirely. Ahead, there is nothing. Not darkness, not emptiness, but a kind of absolute absence, a place where the very concept of seeing ceases to apply. For seeing requires light, and light here no longer carries messages outward. You fall into a silence of vision, a blindness imposed by the geometry of space-time itself. And yet, your journey continues. The inner world of the black hole is not static. It is dynamic, changing with every heartbeat of collapse. Matter that once belonged to stars, planets, and dust now swirls around you, spiraling inward on its own doomed path. The interior is not empty, but crowded with all the debris the black hole has consumed. Yet this matter does not behave as matter should. It is compressed, heated, transformed into states beyond recognition. At such densities, atoms do not exist. Nuclei collapse. Protons may dissolve into quarks, quarks into something stranger still. The inside of the darkness is a cauldron of extremes, a laboratory of matter at the edge of comprehension. The strange thing is that, despite the violence, you might not feel it. Relativity teaches us that locally, right where you are, physics still feels normal. You float in your ship, you breathe your air, you feel the same weight on your body. It is only when you compare your clock to the universe outside, only when you look beyond your local bubble, that the distortions become evident. This is one of the paradoxes of relativity. The laws of physics feel familiar, even as they carry you into the most alien place imaginable. Speculation paints even stranger pictures. Some physicists suggest that deep inside, the singularity may not be a point, but a ring. In solutions known as Kerr black holes, rotating black holes, the singularity forms not as a point, but as a rotating loop. The interior structure may be radically different, with corridors of spacetime that could, in theory, allow passage through. Others imagine that the collapse halts before infinity, forming a finite structure hidden inside, perhaps a Planck star, glowing faintly in a place no light can escape. In these visions, the darkness hides not only destruction, but possibility. To describe such things is to admit how little we know. The strange world inside the darkness is, above all, unknowable, at least for now. Our telescopes cannot see it. Our instruments cannot measure it. Our equations falter in its depths. And yet, it beckons us. It haunts our dreams of the cosmos, reminding us that the universe is larger and stranger than our senses. It is a mystery so complete that even our imagination struggles to picture it. What, then, is the value of imagining? It is this. By daring to picture the inside, we prepare ourselves for discoveries yet to come. We admit that our understanding is partial, and we open ourselves to wonder. For perhaps the strangest truth of all is that the black hole's interior may not be forever hidden. Quantum mechanics tells us that black holes evaporate, however slowly. If they vanish in time, what becomes of their insides? Do they dissolve back into the universe? Do they spill their secrets at the end of their lives? Or does the singularity vanish without a trace, leaving its mystery intact? These questions remind us that the story of the darkness is not finished. It is still unfolding, still waiting for us to write its final chapters. For now, though, we remain outside, imagining. We picture spaghettified travelers, distorted stars, swirling debris, and the silent pull of inevitability. We see the darkness not as emptiness, but as a hidden world sealed away by the horizon. And though we may never walk its paths, we cannot resist wondering what it would be like to do so. The strange world inside the darkness is not merely the inside of a black hole. It is the inside of our own curiosity. It is the space where knowledge fails and imagination begins, where we confront the limits of science and the boundlessness of wonder. To speak of it is not to describe reality, but to admit our longing for it. And so we dream of the inside, painting its unseen shapes with the colors of speculation, filling its silence with the music of thought. Perhaps someday, in some future we cannot yet imagine, we will find ways to glimpse it more directly. Until then, the darkness remains, deep and inscrutable, holding its secrets in the silence of the abyss. The universe reborn. The singularity is most often imagined as an ending, the final collapse of matter and time, the place where existence itself is swallowed into silence. Yet there is another vision, more daring, more audacious, that the singularity is not a grave, but a womb, that what appears to us as death from one perspective may from another be birth. This idea that black holes may seed new universes has long lingered at the edge of scientific speculation. It is bold, unsettling, and strangely comforting all at once. For if it is true, then every black hole may be a doorway, and every singularity a beginning. To consider this, we must turn first to our own universe. Nearly 14 billion years ago, all that we know, the galaxies, the stars, the atoms in our bodies, was compressed into something unimaginably small. The Big Bang is our origin story, the moment when time and space themselves came into being. Yet even here lies a riddle. What precisely was the Big Bang? Was it truly a singularity? If we trace the universe backward through its expansion, density rises, temperature soars, distances shrink. At the ultimate limit, relativity predicts an infinity. But as with black holes, infinity may not be real. It may be the sign of new physics waiting beyond our current understanding. And so, some physicists propose that the birth of our universe was not creation ex nihilo, not something from nothing, but a transformation. That what we call the Big Bang may have been the bounce from a collapsing universe before ours, or the budding of space and time from a singularity in another cosmos. In this vision, universes beget universes, like trees casting seeds into the void. Our own cosmos, vast and ancient as it seems, may be the child of another, hidden forever beyond our horizon. If so, then perhaps black holes are the engines of this cosmic reproduction. Every time a massive star collapses, every time a black hole forms, the process may not end at the singularity. Instead, within that hidden core, the collapse may ignite a new expansion, birthing a pocket universe detached from our own. From the outside, all we see is the black hole, silent and inscrutable. From the inside, a new cosmos unfolds with its own time, its own space, its own destiny. To its inhabitants, the singularity of birth is invisible, just as ours is to us. They see only their own expanding universe, never guessing it began inside the death of a star in another. This idea has a haunting symmetry. Stars die, black holes form, singularities emerge, and from those singularities, new universes are born. Death feeds birth. Endings give rise to beginnings. The cycle continues, endlessly, weaving a tapestry of realities beyond number. The multiverse, if it exists, may be less like a collection of parallel worlds floating side by side, and more like a branching tree of creation, each black hole a seed, each singularity a sprouting root. But could such a process really occur? Physics hints at ways it might. In loop quantum gravity, the collapse of matter may reach a point where space-time itself resists further compression. Instead of ending in a singularity, the collapse bounces, triggering an expansion. This bounce could occur not in our universe, but in a new one, separated from ours by the event horizon. From our side, the black hole continues to exist, dark and silent. From the other side, a new Big Bang erupts, filling a fresh cosmos with matter, energy, and time. In this sense, the singularity is a passage, the thin veil between death and rebirth. Even more tantalizing is the idea that the laws of physics in these child universes may differ slightly from ours. Perhaps the constants of nature, the strength of gravity, the charge of the electron, the speed of light, shift subtly with each new birth. If so, then universes may evolve, shaped by the conditions of their origins. In such a scheme, those universes whose laws allow stars and black holes to form would produce more children, while those whose laws forbid such structures would fade without descendants. Over time, the multiverse would be populated by universes rich in black holes, universes like ours. In this view, we are not here by accident, but by selection, part of a cosmic process of natural evolution on the grandest scale. It is a humbling thought. When we gaze at the night sky, we are not merely looking at stars, but perhaps at the machinery of creation itself. Each black hole, invisible though it may be, could be a gateway, its singularity the spark of another universe. And within those universes, there may be other stars, other galaxies, other beings gazing at their skies, wondering as we do where it all began. They cannot see us, just as we cannot see them, but perhaps our realities are linked, branches of the same cosmic tree. Speculation, yes, but speculation with purpose. For it may be that only by considering such bold ideas can we ever approach the truth of singularities. They are not places where knowledge ends, but where imagination begins. The possibility of universe making is not simply fantasy. It emerges naturally from the same equations that describe black holes and cosmology. Relativity and quantum theory, when pushed together, often whisper of bounces, tunnels, and births. They tell us that collapse and expansion are not opposites, but partners in a cosmic dance. And even if we cannot yet test these ideas directly, hints may still reach us. Hawking radiation, gravitational waves, the subtle imprints of black holes on surrounding space, all may carry clues to the nature of the singularity within. If black holes truly birth universes, then the signature of that process may someday be glimpsed in the echoes they leave behind. We do not yet know what form those echoes will take, but we listen, with instruments tuned to the silence of the cosmos, waiting for the faintest whisper. There is, too, a deeper meaning in this vision of rebirth. For if the singularity is not destruction, but creation, then the universe is far less hostile than it first appears. Black holes cease to be monsters devouring all that approaches. They become midwives of new existence, guardians of the cycle of time. Even death itself takes on a different meaning, not as an absolute end, but as a transformation into something greater. This shift of perspective does not erase the terror of the abyss, but it tempers it with wonder. It reminds us that what we fear as final may, in truth, be the beginning of something unimaginably vast. And so, we return to the thought with which this chapter began, that our own universe may have been born from such a singularity. If that is so, then our cosmos is not isolated, not alone. We are part of a lineage, the child of another reality, the parent perhaps of others yet unborn. The stars above us are not just lights, but reminders that creation is ongoing, that the abyss gives birth even as it consumes. To live in such a universe is to live in a story without end, a story in which every chapter closes only to make way for another. Perhaps one day we will understand this process more clearly. Perhaps one day we will even prove it. Until then, the vision remains a dream, a haunting and beautiful possibility. The singularity, once seen as the edge of knowledge, becomes instead the fountainhead of existence. It is not merely the collapse of physics, it is the rebirth of the cosmos itself. And as we let that vision settle in our minds, we feel a strange peace. For even in the deepest darkness, even in the silence of the abyss, the universe may be whispering not of endings, but of beginnings. The observer's paradox. Black holes are not silent only because they trap light. They are silent because they trap truth. What actually happens inside them is hidden behind the veil of the event horizon, inaccessible to every telescope and probe. And yet, curiously, the mystery of black holes is not only about what happens to those who fall in. It is equally about what happens to those who watch from outside. The paradox of the observer is one of the most profound riddles of modern physics. How can two observers, one falling into a black hole, the other watching safely from a distance, see entirely different realities, and yet both be correct? Imagine yourself floating far from the black hole, your instruments locked onto a spacecraft approaching the horizon. You watch as it draws closer, its engines flaring, its hull catching the light of distant stars. At first, everything appears normal, but then, as the ship nears the horizon, you begin to notice something strange. Its signals take longer to reach you, its lights grow redder, its movements slower. The closer it gets, the slower it appears to move, until finally, just above the horizon, it seems to stop altogether, frozen, forever on the edge. If you could wait for eternity, you would never see it cross. The ship, to you, never truly enters the black hole. It hangs suspended, time itself stretched into infinity. This is your truth, the truth of the distant observer. But now imagine being aboard that very ship. To you, nothing unusual occurs as you cross the horizon. Your engines hum, your watch ticks, your heartbeat continues its rhythm. You pass the threshold in a moment, not even noticing a change. Beyond lies only the continuing fall, deeper into the darkness, toward the singularity that awaits. This is your truth, the truth of the infalling traveler. Two truths, both consistent, both irreconcilable. How can this be? How can reality hold two stories at once, each true within its own frame? This is the essence of the observer's paradox. Relativity insists that both accounts are valid, that each observer measures a reality shaped by their position in spacetime. But our human intuition rebels. We want one story, one reality. The black hole gives us two. And this paradox grows sharper when we consider information. If the ship never crosses the horizon from your perspective, then its information, its signals, its matter, its history remains frozen on the edge. But from the ship's own perspective, all that information plunges inward, gone forever. Which is it? Is the information still at the surface, or is it consumed within? To quantum mechanics, this question is not trivial, for information, once lost, is lost forever. And yet, quantum theory tells us that information cannot be destroyed. Relativity seems to say it can. Thus, the paradox deepens, becoming not just about observers, but about the very foundations of physics. Stephen Hawking added another layer to this riddle in the 1970s, when he showed that black holes radiate faint energy, Hawking radiation, caused by quantum fluctuations at the horizon. Over vast stretches of time, this radiation could cause a black hole to evaporate completely. But if it vanishes, what happens to all the information it consumed? Is it erased from the universe, violating the sacred rules of quantum mechanics? Or is it somehow encoded in the radiation, hidden in correlations too subtle for us to yet detect? This is the black hole information paradox, and it is one of the great unsolved mysteries of our age. Some physicists suggest that the paradox resolves through holography. To the outside observer, everything that falls into a black hole is smeared across the horizon, encoded in its surface area like a cosmic memory. To the infalling traveler, reality is different. They pass through freely, experiencing the fall. Both perspectives are true, but neither is complete. The black hole, in this picture, is like a two-faced mirror, showing different images to different viewers. The paradox remains, but it softens, transformed from contradiction into complement. Others push the imagination further. Perhaps the horizon itself is a kind of firewall, a searing boundary where information is destroyed before entry. If so, then the infalling traveler does not pass peacefully. They are incinerated at the surface, their story ending in fire, not silence. This firewall paradox remains controversial, for it challenges the principle that physics should look normal to a falling observer. If true, it would rewrite our understanding of black holes entirely. If false, then another solution must wait for us to uncover. The observer's paradox is not limited to black holes alone. It whispers to us about the nature of reality itself. For it suggests that truth is not singular, but relative, that what you see and what I see may both be real, even if they cannot be reconciled. At cosmic scales, this relativity is dramatic. At human scales, it is subtler, but no less profound. Time moves differently for each of us, shaped by our speed, our gravity, our perspective. The black hole simply magnifies this to an extreme, forcing us to confront what we normally ignore, that reality is woven from many threads, not one. And yet, the paradox does not let us rest easily. It reminds us that our theories remain incomplete. Somewhere, hidden in the mathematics, lies a deeper framework that will reconcile the frozen ship and the falling traveler, the stored information and the consumed matter, the radiation and the horizon. That framework, many believe, will be the long-sought union of quantum mechanics and relativity, the theory of quantum gravity. Until then, the observer's paradox remains, a riddle without resolution, a challenge to the future of science. But perhaps the paradox is not a flaw. Perhaps it is a gift, for it reveals something essential about the universe, that it cannot be reduced to a single viewpoint. That truth is richer than any one perspective. That to understand the whole, we must weave together the partial stories of all observers. This is not only physics, it is philosophy, even poetry, for it echoes the human condition itself, that no one of us sees reality in full, but together our truths may form a larger picture. Still, when we return to the black hole, the paradox weighs heavily. We cannot shake the image, the traveler falling silently inward, the observer watching them freeze forever at the edge. Two stories side by side, never touching, never agreeing. Which do we trust? Which do we believe? Perhaps the answer is that we must believe both, even if our minds resist. And so, the black hole becomes not only a challenge to physics, but a mirror to our own limitations. It forces us to admit that reality is stranger, deeper, more layered than we thought. That the universe does not bend to our demand for singular truths. That sometimes the paradox is the truth. In this way, the observer's paradox is not a problem to be solved, but an invitation to humility. It reminds us that we are small, that our perspectives are partial, that the cosmos is vast beyond comprehension. And yet, it also reminds us that our questions matter, that by asking them we draw closer to the heart of the mystery. The singularity waits, the horizon hides, and we remain outside, caught between stories. We may never reconcile them fully, but in the asking, in the wondering, we discover something greater than certainty. We discover awe, the human question. In the end, the strange world inside a singularity is not only a question about physics, it is also a question about us. We can speak of horizons and infinities, of wormholes and quantum foam, of information paradoxes and holographic principles, but beneath all of it lies something quieter, more fragile, more human. Why do we care? Why does the thought of a singularity haunt us, call to us, even frighten us? What is it about these silent abysses in the fabric of spacetime that reaches into our lives, our stories, our sense of who we are? Perhaps it begins with curiosity. Human beings have always stood at the edges of mysteries, staring outward and wondering. Once, those mysteries were oceans, forests, mountains. Later, they became atoms, cells, galaxies. Always we are drawn to the places we cannot see, to the questions we cannot answer. The singularity is the ultimate of these places. It is the frontier where not just our eyes, but our very minds falter. To imagine it is to admit our ignorance, and yet we cannot look away. For we are creatures who live on questions as much as on food or air. But there is more than curiosity here. There is fear. For the singularity is not only a riddle, it is also a reminder of endings. To cross its horizon is to vanish, to lose not only your life, but your very place in the story of the universe. No message returns, no memory survives. It is oblivion made physical. And as we think about it, we cannot help but think of our own mortality, the horizons that await each of us, the silences that none can cross. The black hole becomes a mirror, reflecting our deepest anxieties about loss and death. And yet, paradoxically, the singularity also offers comfort, for in its silence may lie rebirth. If black holes do indeed seed new universes, then endings are never absolute. They are transformations, passages into something larger. Even the death of a star can give rise to a new cosmos. For us, this offers a strange hope, that perhaps death too is not an end, but a beginning, that even the silence may hold new stories waiting to unfold. The singularity whispers both doom and promise, destruction and creation. It is as ambivalent as life itself. This is why the singularity matters beyond physics. It touches the human heart. It asks us questions we have always asked ourselves. What is time? What is death? What is meaning? Where do we come from? Where are we going? In its darkness, we see not only the collapse of equations, but the reflection of our own search for purpose. And so, the human question becomes this: what do we do with the mystery? Do we treat it as a wall, a place where knowledge ends and imagination stops? Or do we treat it as a doorway, a place where wonder begins? For centuries, humans have chosen the latter. We build telescopes to peer into the void, detectors to listen to the whispers of gravitational waves, instruments to trace the faint shadows of horizons. We weave theories, daring and strange, to imagine what lies inside. We tell stories, some scientific, some mythic, some poetic, each one a way of reaching toward the unreachable. In doing so, we transform the abyss from a place of fear into a place of inspiration. The singularity also teaches us humility. It reminds us that our proudest achievements, our most elegant theories, our deepest insights are still partial. That the universe is not ours to command, but ours to explore with reverence and awe. It reminds us that we are small, and yet that smallness is not weakness. For in being small, we can marvel. We can stand before the infinite and feel wonder instead of despair. We can admit we do not know, and in that admission lies the seed of discovery. It may be that we will never know the full truth of singularities. Perhaps they will remain forever hidden, their mysteries sealed away by horizons we cannot cross. But even if that is so, the journey has already given us much. It has forced us to invent new ways of thinking, new tools of measurement, new philosophies of time and space. It has united the vastness of relativity with the subtlety of quantum mechanics, even as it challenges them both. It has shown us that reality is stranger, deeper, more layered than we imagined. In chasing the singularity, we have already expanded ourselves. And in the end, that may be the real answer to the human question. The singularity matters not because we will solve it, but because it changes us to try. The act of wondering, of asking, of imagining is itself transformative. It lifts us out of the ordinary, reminds us that we are participants in a cosmos beyond comprehension. It keeps alive the flame of awe that has guided us since the first time a human being looked at the stars and whispered, "What is that?" So, when we think of the strange world inside a singularity, perhaps we should not ask only what it is, but what it does to us. It humbles us, it frightens us, it inspires us. It draws us together, scientists and dreamers, philosophers and poets, each trying in their own way to touch the untouchable. It teaches us that the unknown is not our enemy, but our greatest companion. For as long as there are horizons, we will walk toward them. As long as there are mysteries, we will ask. As long as there are singularities, we will imagine. And maybe that is the greatest paradox of all, that in the places where physics collapses, humanity is strengthened. That in the silence of the abyss, our voices grow louder. That in the shadow of the singularity, we find not emptiness, but meaning. The strange world inside a singularity may remain forever hidden, but the strange world inside us, the curiosity, the wonder, the courage that is revealed by our search for it. In seeking the unknown, we discover ourselves, and that, perhaps, is the truest answer of all.